Welcome, Hornets, and thank you for joining me today. Today we're going to be talking about trying to graph a secant or cosecant graph. And we're going to be talking about them in terms of their asymptotes. So let's begin by stating where are the asymptotes of a secant and a cosecant. So when we have a secant theta, and we say that secant theta is going to have to equal something that is a real number. Now, we know that the secant has asymptotes whenever we had a denominator that had a zero. This occurred at pi over 2, 3 pi over 2. So we now have a pi over 2 and 3 pi over 2, which means that 5 pi over 2 is also an asymptote, 7 pi over 2 is an asymptote, negative pi over 2 is an asymptote, negative 3 pi over 2 is an asymptote. All of these are asymptotes. And you'll notice that they're separated by a pi each and every single time, which means that we can write this as a secant. Theta will have an asymptote every time we have a pi over 2 plus pi k, where k is an element of the integer set. Okay, so we're now talking about it in terms of a sequence or a series of values. If you recall from your Algebra 2, perhaps, when you were working with a sequence of values, you'll recall that we had arithmetic sequences. This is an example of an arithmetic sequence, where I have a value where I begin, and then I add a certain amount that is consistent each and every time. So here we're looking at the asymptotes of a secant. So if I were saying, oh, well, gee, I have this function secant of, let's say, 2 theta minus pi over 5 plus 3, and we have a 2 equals y. Now we're going to have to approach this the same way that we did for our complex trigonometry. And that means that we're going to have to equate this piece right here with our asymptotes. Now, currently, the graph of a secant is the inverse of a cosine. Now, if we were to draw the graph of a cosine, and keep in mind I'm just drawing a very rough sketch of a graph, I can see that here is my pi over 2 for the cosine, and here is 3 pi over 2 for the cosine, forcing my asymptotes to be here. Now, because this is the inverse, or the reciprocal of a cosine, our maximums become minimums, and vice versa. So here we have another asymptote right here. This is at 5 pi. So we have 3 pi over 2, 5 pi over 2, and pi over 2. And right here, our maximum becomes a minimum, just like our minimum became a maximum. Now, that means that we have our center line sitting right here. This was the amplitude of our cosine, which means that we're going to have our A value plus our D value. And this would be our A value minus our D value. Okay, so notice we're going to be first starting with our center line and our maximum and minimum values. Then we're going to find what is the theta that will give me that asymptote of pi over 2, then 3 pi over 2, then 5 pi over 2, and if we can see a pattern, we're going to go with it. All right, so let's go ahead and now let's look at our work. We're going to graph y equals 2 secant 2 theta minus pi over 5 plus 3. Start with my graph, and I'm going to locate positive 3, and then I'm going to go up 2 and down 2. So 1, 2, 3, up 2, and down 2. So here's my center line. Here is the down 2, where we will have all of our relative maximums. That's going to be these values right down here. At 5, we're going to have all of those relative minimums. That's this portion here. So all I need now are my asymptotes, and then halfway in between those asymptotes is the location of these maximums and minimums. So here we go. We're going to start with pi over 2. We want theta to be pi over 2. We have 2 theta minus pi over 5, and we're ready to begin. We divide both sides by 2. We get pi over 4. We're going to add pi over 5, and this will be our first theta. Common denominator is 20ths, so I have 5 plus 4 20ths. This is giving me 9 pi 20ths. We're now going to repeat that with 3 pi over 2. 3 pi over 2 equals 2 theta minus pi over 5. That's going to give me 3 pi over 4 plus pi over 5. That's going to give me 15 plus 4 20ths for 19 pi 20ths. All right. So we can now see that we went 10 20ths. Okay? To go from 9 pi to 19 pi, I've gone 10 20ths. So I'm now going to mark 9 20ths. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my first asymptote. And I'm going to put it in. My second asymptote is at 19 pi. So I'm now going to count 10 markers over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here is my second asymptote. Now, we now know that all of the asymptotes are 10 apart. This was the equivalent of pi over 2, which means that if I move 1 over, I'm at the equivalent negative pi over 2. Okay. So this was 9 pi over 20. Theta equals 9 pi over 20. Theta equals negative 1 pi over 20. Theta equals 19 pi over 20. And we're going to go over another grouping of 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now this is going to be 29 pi over 20. Theta equals 29 pi over 20. Alrighty, we're now ready to do what we need to. So we need to go halfway. So negative 1 to 0. Then we go 1/20, 2/20ths, 3/20ths, 4/20ths. This right here is halfway. This is my halfway mark. And it is 4/20ths pi. Let's just make sure we note that down over on the side. 4 pi over 20 is pi over 5. Okay, so we now have our pi over 5. And if you recall, we go down first, then up. This is going to have to go like this. And then down. I'm now going to plot this point. This point is at 1, and it was at pi over 5. Pi over 5, comma 1. Let's make sure I've got that right. Let's just check. So if I do pi over 5, I think I'm off by 90 degrees. I'm going to show you why. After all, this was my equivalent pi over 2. And therefore it would be 1, 2, 3, 4, 5 over here, putting this at the top. So this would be pi over 5, comma 5, and it opens up. There we go. Now we've got what we need. This has to be the one going down now. Now you could check it by just plugging in. For example, if I put in the pi over 5, which I was doing, I'm going to get a 0. 0 times 2 is 0. The secant of 0 is 1. 1 times 2 makes 2, plus 3 makes 5. So I know it has to be 5. So I can always check by plugging in the value that I was just working with, just to make sure. You'll notice in this case, it is to my advantage to check. So let's just keep going. This was 9, 10, 11, 12, 13, 14 pi over 20. And I'm going to reduce that 14 pi over 20 so that I get 7/10 pi. This is now 7/10 pi, and it is at 1. That makes this one going over 1, 2, 3, 4, 5, halfway in between. Has to now be up. Let's just find out what that is. That's 19 here, 20, 21, 22, 23, 24. 24 pi 20ths is going to be 12/10 pi, which is 6/5 pi. We're drawing my curve and plotting 6/5 pi 5. Alrighty, so let's repeat what we did. We started with our center line. This was the y equals 3. We then went up 2 and down 2 in order to find where the maximums and minimums are going to be. We know that our secant is always going to have the maximums and minimums flipping. So the maximum is going to be in between the pi over 2 and 3 pi over 2, located at pi. Whereas at, 2 pi, we know we're going to be at 1. We also know we're at 1 here at 0 pi. Okay? So once I found where my maximums and minimums were, I then began by equating 9 pi over 20, and it had to be equal to this piece right here. Pi over 2, where the first asymptote was, had to be equated to 2 times theta minus pi over 5. I then solved to get 9 pi over 20. I then took the next known asymptote, which is at 3 pi over 2, and I found where that theta was. I then made sure I put in the 2 asymptotes and counted the distance. The distance between the 2 asymptotes is the length that we need to consistently draw between them. So if this is 10, I can go 10 over, which allowed me to find 29 pi over 20. I then was able to go backwards to negative pi over 20. I then started by plugging in, and you'll recall I started with what this middle part was, and this was pi over 20. 4 pi over 20 reduces to pi over 5, which I plug in. That gives me 0 pi. So I'm looking at 0. 0 we know is 1 for cosine, for the secant. So I multiplied 1 times 2, gave me 2, and added 3. And that was my first point. 7 pi over 10, we can do the same thing. We're going to get 5 pi over 10 minus 7 pi over 10. We're going to be left with our pi over 2 times 2 gives me pi. That is negative 1. The secant of pi is negative 1. So I multiply by the 2. That gives me negative 2 and add 3, and I'm now at 1. We then went halfway through. That's how we found 6 pi over 5. That's the halfway distance between 19 pi over 20 and 29 pi over 20. We then found what that was and used our pattern. Up, down, up. And we can continue with this for as many periods as we want by simply counting 10 out, going halfway, and plugging it in. Alrighty, this was for secant. The next video will be on cosecant. Thank you very much. I hope this has helped. Please remember to click like if you find this useful. Bye-bye now. Cheers.